Hello and welcome. I am Vivian Fernandez. In this program, we'll discuss why Delhi's biodiversity park should be scaled up from 7 currently to the entire 22-kilometer city stretch of the Yamuna. This could also be a template for other cities along the Yamuna and the Ganga. This is because most North Indian cities have very poor air quality due to high dust and other particulate matter. There are also hot spots in summer where wet bulb temperatures or a combination of high heat and high humidity could go beyond human endurance levels. To discuss this, we have with us Professor C.R. Babu, founding director of Delhi University Center for Environmental Management of Degraded Ecosystems, or CEMDE. Also joining us briefly is Yamini Gupta, professor of finance and business economics at Delhi University, who has estimated carbon capture at one of Delhi's biodiversity parks. Our other guest is Dr. Vivek Chaudhary, CEMD's CMD is scientist in charge of Tughlakabad Biodiversity Park. Under Professor Babu's guidance, he has also reclaimed a 200-acre dolomite and limestone quarry at Rourkela in Odisha. Professor Babu, Professor Gupta, and Dr. Vivek Chaudhary, welcome. Thanks for making the time. Professor Babu, first question to you. Now, when we talk of biodiversity parks, we think of them as prettified urban forests where people come for picnicking and bird watching. But are they manicured forests, or are they just artificially incubated jungles?
The river system is a complex network of ecosystems, all of which are highly ecological integrated and function as one system. I must tell you that the river ecosystem is a living system. For example, what are the kinds of different ecosystems that constitute to the river ecosystem? For example, the channel or the water course ecosystem, which is called as flowing water ecosystem, the riparian zone, which is very close to the channel, and then the floodplain ecosystem, which contains a wide range of what you call small ecosystems. And then you have within the floodplain, you have an active floodplain ecosystem, and an inactive floodplain ecosystem or the old ecosystem. Then you have an embankment ecosystem, and you have an upland ecosystem. Now, all these ecosystems work together and contribute to what you call not only the quantity, quality of river water, but also the amount of water that is available in the groundwater system. Besides this, these river ecosystems also contribute to what you call reduction in the heat load, and what you call able to what you call wet the air in the cities or around the area, and also I must tell you buffer the ambient temperature, or otherwise regulate the local weather conditions, which is very, 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 very critical. And most important thing is they're able to sequester CO2 and other pollutants, so that the city or the towns or the human settlements in and around these river systems would what you call make the environmental quality extremely high, and therefore the quality of life is much what you call better. In other words, the river ecosystems contribute to the sustainability, environmental sustainability of the human settlements in and around it.
So, okay. Professor Babu, if I get you right, what you are saying is the vegetation of a river,
yes,
it contributes to it. It's a heat sink. It absorbs particulate matter. It scrubs the air of particulate matter and
yes,
absorbs greenhouse gases. It also stores flood water and also purifies river water. So it performs multiple functions. Now, when you started the Yamuna Biodiversity Park in 2002, what did you do there? I mean, To what extent is that Yamuna Biodiversity Park an artificial park, and what is the extent of human intervention? Did you just incubate the park so that the jungle could take over after that?
Now, what we did as a part of development of biodiversity parks, our first job is restore the wetlands back to their original status, their original system. We restored the silted wetlands in both active floodplain as well as the what you call inactive floodplain. Now, we have a wetlands in the active floodplain which receive huge quantity of what you call flood water and store it and recharge the groundwater.
When you started reclaiming the wetlands, what did you do? Did you have to do a lot of excavation? Did you have to move a lot of earth from that area? What
I
was the
must tell
extent
you,
of the intervention?
yes, I must tell you what are the steps that are involved in the restoration of the wetlands. We desilt the material by excavating the earth up to a depth of 3 to 5 meters. And in some cases, we have gone up to 6 to 7 meters in the central portion, but gradually what you're shallowing towards the shoreline. And this would provide you the natural contours of a wetland and would able to store the groundwater as well as develop a variety of aquatic vegetation. We, after what we call desilting, the desilted material, we use it for landscaping some other area, and we introduce a wide range of aquatic plants. And once we introduce the aquatic plants, and then we have also introduced some fish fingerlings, with the result, the entire ecosystem has come back. And today,
Professor, when you say that you introduced these plants, did you bring them from somewhere outside, or were they all native to the Yamuna?
Now, I must tell you, all these aquatic plants which we have introduced are what you call collected from the existing wetlands that are present along the floodplains of the river Yamuna. We have not introduced any exotic species or any other species. We just, since there's nothing in these wetlands, we brought them and then we introduced, and they multiplied themselves, and now they established a full-fledged ecosystem. Now,
so can we say, Professor, that what you have done at Yamuna Biodiversity Park and at the other parks is basically a recreation of the vegetation that existed along the Yamuna before urbanization destroyed it?
This is you're given a right answer. What we did is we recreated the entire biodiversity, right, which was vanished because of urbanization, because of many anthropogenic factors, and then brought it back to a natural state of ecosystem. And these ecosystems are fully functioning now. We have now let me tell you, these are my catchment wetlands. I have a treatment wetlands where I utilize that wetlands for the treatment of wastewater that enters into the Yamuna, and that makes sewage water into a clean water. And these are called treatment wetlands. So we have restored catchment wetlands, we have restored treatment wetlands, and then we developed also grasslands, and we restored marshes and a floodplain forest. And
okay.
In this,
so I was at one of your presentation, and you spoke about a tropic cascade.
Yes.
Now, I think that is what you are describing now. You are talking about grasslands, you are talking about trees, you are talking about shrubs. Can you just elaborate on this tropic cascade? What is it? What is this? What is this tropic cascade?
Whether it is in a wetland ecosystem or whether it's a terrestrial forest ecosystem, you have what you call different levels of different levels of trophic structure. For example, you have an autotrophs. The autotrophs would provide a food to a set of animals known as herbivores. These herbivores will provide a food to a set of another group of animals known as primary carnivores. And then the primary carnivores will serve as a food for another set of higher organisms known as secondary carnivores. The secondary carnivores are your tiger, the leopard, and many other animals. The primary carnivores would be small cats and jackals and other carnivores. And then herbivores are mostly the small, like Indian hare, and many other squirrels and many other animals constitute the herbivores. And autotrophs are the plants. Now,
okay.
with
And
this
you also have trees, and you also have trees at various levels. You have
yes,
stone
we have
age
a,
forests. Yes.
that is a stratification of the forest. Now, you have a ground vegetation, you have a underwood understory consisting of a shrub layer and a medium-sized layer, and then you have a tall trees which constitute the upper story. In other words, we have a forest communities ranging from 3-story to 4-story, and this 3 and 4-story forest ecosystem would increase the ecological diversity. As a result, you find once the ecological diversity is increased, the animals come on their own and would be able to live comfortably, coexist with the rest of the components of the ecosystem.
Okay.
Now, this
one more question to you, Professor.
This process is called rewilding of the what you call the biodiversity parks that we have established, and that is taking place.
One more question to you before I go to Professor Yamini. Can you tell us how many species, biological species, do you have over there in the park?
Let me tell you that in all our 7 biodiversity parks, we have about roughly 3,000 species of plants and animals living together in the form of 75 to 100 biological communities representing 15 ecosystems. But in Yamuna Biodiversity Park, we have about 1,200 species living together in the form of 35 to 40 communities representing about 8 to 10 ecosystems. These are fully functional and providing a wide range of ecological services worth of several millions of rupees annually.
Professor Gupta, coming to your study, now you have done an assessment of carbon capture by adult trees at the Aravali Biodiversity Park. Can you briefly tell us what you have found?
So we've used a benefit transfer approach to assign economic value to the services provided by these adult trees, as you mentioned, in Aravali Biodiversity Park. We chose trees that were 15 to 18 years old from 183 samples of 100 square meters of land randomly distributed over the park. And we finally had a total number of 829 trees that we've sampled. These consist of 79 species. And we calculated carbon storage in tons, the gross carbon sequestered in tons per year, and also avoided runoff and pollution removal by these trees.
Can you give us those numbers?
Yeah. So in terms of carbon storage for the 829 trees, it comes to about 37 tons. And if we extrapolate this number to the 500 acres of the park, which are forested, then it comes to about 9,000 tons of carbon. And in terms of gross carbon sequestration for 2 lakh trees in 500 acres, it would be about 1,253 tons per year of carbon sequestered. And similarly, the presence of 2 lakh trees gives us an avoided runoff value of about 1,10,000 cubic feet per year and pollution removal of about 14 tons.
Mm-hmm. So 9,000 tons of carbon stored in the tree trunks of these adult trees.
Yes.
1,200 tons of carbon dioxide equivalent sequestered every year,
Yes.
plus the avoided rainwater runoff of
Right.
more than a lakh cubic
Cubic
feet.
feet. Yes.
Yes, and
And
then
about
greenhouse
14
gas.
tons of pollution removal.
Now in Delhi, according to a study done by two IIT professors of Kanpur, or rather two professors of IIT Kanpur in 2014 for the Department of Environment Delhi Administration, they estimated that Delhi was dumping about 38 million tons of carbon
Carbon.
dioxide equivalent every year. So 9,000 tons would be a drop in the ocean of pollution, of Delhi's pollution. But you have not calculated, the carbon sequestered by a whole lot of other plants and trees over there, isn't it?
Yes, this study is a very preliminary study, and it's only focused on these adult trees. And we still need to do a similar exercise for carbon stored in soil. And like Professor Babu mentioned, at the ground level, at the medium height level, those studies need to be done yet to get a more comprehensive idea of how much carbon is being stored by this park.
So the carbon will be stored by grasses and plants and by organic matter in the soil, as well as by young trees.
Yes,
Yeah.
shrubs and younger trees, yes.
So what you are saying is that, you are actually giving a very high ambition for Professor Babu, because 9,000 tons stored is not enough. And that is why we began this discussion by saying that we must convert the entire 22 kilometer city stretch of the Yamuna to biodiversity parks. Professor Yamuna, thank you very much for joining us. I would now like to come back to Professor Babu and also to Dr. Chaudhary. Dr. Chaudhary, can you tell us, you are doing the Tughlakabad Biodiversity Park. What are the kind of challenges that you face? Because that will give us an idea about the challenges we'll face if we are going to scale up the biodiversity parks along the entire stretch of the Yamuna.
Say, actually, this is part of southern Ridge area, and we have some problem with cattle. We have monkey menace, and this is actually natural. And apart from this, we have problem with also some alien species, because this land was earlier, nobody has scientifically worked here. So we have huge patch of this Prosophis julifera, which is
Vilayati kicker.
So our natural habitat competing with those Vilayati kicker,
which is a parasitic tree.
Yes, sir. And we have also lantana and other alien species. So whenever no any scientific approach there, definitely that place become heaven for those exotic species. So that situation existing here, we are struggling with that. And apart from that, we have, being a ridge area and uncertainty in monsoon, we are also struggling with this irrigation. But we have our facility. We are using our wetland. We are getting water through STP plant. So we are coping with all those. But after all, what I want to say that we are developing, and we are, step by step, we are moving towards what we have successful story like Aravali.
When we're talking about developing the diversity park along the entire stretch of the Yamuna, how doable is it? Why did you not attempt it all these years? Because the National Green Tribunal had in orders passed in July 2018 and August 2018 endorsed the idea of biodiversity parks, and they had said that your model should be replicated along the Yamuna as well as the Ganga. So why have we not proceeded with that suggestion?
Sir, the issue is, sir, let me tell you, sir. It is very important to develop biodiversity parks all along the floodplains of all our rivers in India, including Ganga and Yamuna. There's no doubt about it. But There are issues of land ownership. There are issues of financial constraints. There are issues of security of the areas. So that's the one which has been delayed. And I must tell you, already our present biodiversity parks have been what you call identified for the riverfront along with Yamuna. And Ganga, a quite good number of biodiversity parks are coming up in UP. And hopefully, in the next 5 years, you find the dream of establishing a network of biodiversity parks along the Delhi stretch of Yamuna would be fulfilled, sir. Would be a reality. Would be reality. And if that happens, sir, I must tell you, the quality of the environment of Delhi is quite good for what you call a meaningful living in the city. With
how much of area would be available, sir, if you were to develop the entire 22 kilometers?
Sir, I must tell you, in the upstream, I am not sure, but we have 9,700 plus hectares of floodplain is available. Now, all of the entire area cannot be developed into a forest. As I already told you, you have in the floodplain, grasslands, you have a wetlands, catchment and treatment wetlands. Then you have a marshes, you have a riparian zone. The elevated area, that is the world floodplains, can be developed into a 3-storied forest, which would serve as a shield against a variety of what you call environmental disasters that may happen in the coming years because of the climate change.
You are not certainly recommending dense forest plants on the banks on the floodplains, because that would prevent the block the flow of monsoon water.
This is precisely, sir. If you have a very high density plantation of very tall trees that provide a resistance to the flow of flood water, and that will result in the what you call buildup of flood water in the upstream, and that result in the breaches of the embankment, and that will lead to a major flooding of the agricultural fields and the surrounding what you call human settlements. So therefore, it's always advisable not to have a dense plantation on the active floodplain, but you can have a dense plantation on the inactive floodplain, which will not receive flood water every year.
Mm-hmm. But in the floodplains where you have grasses, these grasses will provide food to various microorganisms, and those microorganisms in turn will absorb much of the pollution that is dumped in the river, isn't it? Heavy metals, for example.
You're right, sir. Actually, the riparian zone has a community which will remove all your heavy metals. It's a very, very important. And then also would able to what you call regulate the nutrients, also regulate the temperature. I just want to tell you, sir, how these biodiversity parks would contribute to the quality of the river water. Sir, one single parameter of water will determine many other parameters. That is water temperature. Higher the water temperature, less the amount of oxygen. If less the amount of oxygen, the lower the microbial activity and diversity, and therefore more accumulation of the pollutants. But if you have a low temperature, more oxygen, more microbial activity, more microbial diversity, and more what you call removal of pollutant removal efficiency is very, very, very high. Mm-hmm. Now, that's the reason why the NGT ordered to establish biodiversity parks all along the floodplains of rivers as a part of rejuvenation of rivers.
Dr. Chaudhary, the model that CMDE has formed, this is not just applicable to the Yamuna or to the Ganga, it's also applicable for the reclamation of abandoned mines. Now, could you tell us what you did in Rourkela at Purnabhani? How did you reclaim that area, and what were the challenges that you faced over there?
See, sir, actually our technology is same, but many times it changes according to site. So many times Professor Babu saying that, it's a site specific. So in Delhi, you have degraded forest, but in mined out area, you have, dead soil, degraded soil. In fact, we say
And you
it's
have that overburden. You have the overburden also.
overburden, dead ecosystem. So
Mhm.
at there, we had biggest challenge to revive soil first.
How did you do that?
That's I just just a few minutes ago I told you that because of legumes, grasses, and all those pioneer species that we have idea that who does what. So we accumulated all those community and we have started work there. And simultaneously we done plantation of all those native species. Professor Babu has made many self-help group involving local tribal lady and all those. They have gone to near about forest area. They brought all those native sapling there. And also sometime we keep objective of local aspiration. So their local is all displaced project affected people. So we include their objective, and they are suffering for they don't have livelihood. So we include their livelihood option there, and created plant community according to them. We convert.
How did you ensure that they could live off these forests? How did you do that?
Sir, we have included all those that they're supposed to do earlier. Before mining, they used to do tasar cultivation. Before mining, they used to do lag cultivation, and we have plenty of their space, which is called mine out wide, which has tremendous amount of water. So that water body we have converted into aquatic ecosystem where we have put thousands of fingerlings, lakhs of fingerlings. So that also become one option of livelihood and also aquatic ecosystem. So combined together, we develop ecosystem, and because local they don't have understanding of carbon sequestration and etc. So what we did, we just connect local so that they can protect it, preserve it.
So were you able to restore the forest that existed before mining happened?
Pardon, sir?
Were you able to restore the forests or the vegetation
Yes,
that
sir.
was there before mining started?
Yes, it's a similar. It's in fact similar to neighborhood natural forest ecosystem.
Okay.
It's a similar to that is actually our goal. Wherever we do ecological restoration, our aim is to bring back native ecosystem, which earlier existed, or in fact, if we do survey
I praise.
of local.
Yes. And so you not only reclaimed the jungle, but you also made sure that the people, the tribal people, they had a means of livelihood. They could grow tussar silk. They could extract lac, as well
Yes,
as
sir.
live off the water by fishing.
Yes, sir. Yes, sir.
And one final question to you about our ambition to have biodiversity parks along the entire Yamuna belt in Delhi. How
Yes, sir.
doable is that in your view?
No. Now is pretty much people are aware. I must tell you, people of Tughlakabad, earlier they thought that we are, what we creating here. So whenever they saw development, now they wanted to entire area, neighborhood. They are coming here to us and they are saying that why you are not developing other area. So people of Delhi, in fact, we are, urban capital and all are aware. So people wanted us. Many times I saw people are coming, civil society are coming to Dr. Fayaz or Professor Babu that why you are not working in another paths. So people are aware, they are demanding actually.
Mhm.
And it's a matter of our survival, because in last couple of this COVID period, people has seen that those which they are getting free, like oxygen and plant and recreational, actually it's costliest.
Mhm.
It's a required for their survival. So people are aware of all that,
Yeah.
and they are
I-
demanding.
I just wanted to tell you, sir,
Yes.
all these biodiversity parks programs are fully funded by DDA. It is
Delhi Development
these-
Authority.
yes. These biodiversity parks are owned by DDA, and they are also playing a very critical role in improving the environmental quality of Delhi. And I think with their help, we will be able to establish a network of biodiversity parks all along the what you call Delhi stretch of Yamuna, to make Delhi a better living place in the world.
Professor Babu, you are chairman of the committee chairman of the 3-member committee on biodiversity parks.
Yes, sir.
We wish you all the best, and I hope the people of Delhi support you wholeheartedly. Professor Babu, thank you very much for joining us. And Dr. Chowdhury, thank you very much as well.
Thank you.
And Dr. Yamini Gupta, who has given us an assessment of carbon capture by one of the parks. Thank you all very much for joining us.
Thank you
Thank
very
you.
much, sir.
Thank you, sir.
Subscribe to the Federal's YouTube page for more interesting updates.